Good morning. Welcome to class 9 ICSE chemistry. Today we are going to solve the sample board examination paper of chemistry. Chemistry is science paper 2. It will be for 2 hours. Section 1 is compulsory and from section 2 we have to attempt any 4 questions, each one carrying 10 marks. If you look at your question 1, which is for 40 marks, you have to answer all questions. Question 1A. Fill in the blanks with correct choice given in brackets. Number 1. An ionic compound. The bond is formed due to electrons. Is it sharing or transfer? Remember, sharing is covalent bond. But here it is ionic, so it will be transfer. Zinc is dash reactive than aluminium. Now zinc is, you have to look at the EC series. So you will see it is zinc is lower in the EC series and so it will be less reactive than aluminium. Third one, the chemical reaction in which heat is absorbed is known as endothermic is correct because exothermic means heat is liberated. Here heat is absorbed. Number 4, the molecular formula of ammonium sulfate is ammonium is NH4, sulfate is SO4, but ammonium has valency 1 plus and sulfate has valency 2 minus. And so it will be NH4 twice SO4 and so it's the second choice. If an element has 2 electrons in the outermost shell, then it is likely to be if there are 2 electrons which are valence electrons, then 1, 2, 3 valence electrons make it metallic, otherwise it is non-metallic. Question 1b will go fast because they are multiple choice questions. Choose the correct answer from the options given below. Number 1, the gas that causes greenhouse effect is methane. Here it is. You need to know these by heart. According to the modern periodic law, the properties of elements are periodic functions of their, it will be atomic number. If you know your definition well. The third one, which of the following is the water of crystallization? It is not this, not this, not this, this, yes. This is Na2CO3 dot 10H2O. The gas which has rotten egg smell is hydrogen sulfide. This is known to be its smell of rotten eggs. The temperature of 0 degrees Celsius on Kelvin scale will be 0 plus 273, which will be B. We come to question C. Name the gas evolved in each of the following cases. Copper carbonate is heated strongly. Now this is a carbonate. Carbonate is having CO3 2 minus as the radical. When you heat this, if it is the metal is lower in the EC series, all carbonates are going to release carbon dioxide. So it will be carbon dioxide. Second one, action of dilute hydrochloric acid on sodium sulfite. Now metallic sulfite, anytime you have the radical sulfite, it is SO3 2 minus, and with the acid which is dilute, you will have H2SO3 formed. Now H2SO3 is a weak acid. it gives out SO2 gas because it splits into H2O and SO2. So SO2 is sulfur dioxide gas. Nitrogen combines with hydrogen. You know this reaction, N2 plus 3H2. Reversible arrow gives you 2NH3. And what gas is that? That's right. It is ammonia. Action of dilute sulfuric acid on sodium carbonate. Now again you will see here this is CO2 will be given out because it is carbonate and it is the dilute acid which will react with this carbonate and it will give you H2CO3. Being a weak acid, it will give us H2O plus CO2 and we will have carbon dioxide. Action of sodium on cold water. Now sodium with cold water is going to split this water and it is going to liberate hydrogen. So our gas is hydrogen. We are coming to question 1D. Give reason for the following. The first one being noble gases do not combine with other elements to form molecules. Now, what do we understand by noble gases? They are group 8 or 18. What else we know? That their valence electrons are either 2 or 8, which means their duplet or octet is complete. So, we will say noble gases have complete duplet or octet which gives them a stable electronic configuration. Hence, they do not need to gain, lose, or share electrons and do not combine with other elements to form compounds. Our second question, dilute nitric acid cannot be used in the preparation of hydrogen. Now, what do we know about nitric acid? It's a strong oxidizing agent. So, it's going to liberate nascent oxygen. Now, hydrogen when it is prepared, immediately that nascent oxygen will attack this and form water. So, we'll try just that. Right? Dilute nitric acid is a strong oxidizing agent and liberates nascent oxygen which combines with hydrogen formed and converts it to water. Hence, dilute nitric acid cannot be used in the preparation of hydrogen. Our next one, hydrogen, although lighter than air, is not collected by downward displacement of air. Now we know that ammonia, being lighter than air, is collected by downward displacement of air, but why not hydrogen? Because hydrogen has a special property due to which with air it forms explosive mixture. So let us write that. Hydrogen forms an explosive mixture with air and hence cannot be collected by downward displacement of air. Anhydrous calcium chloride, the fourth one, turns into colorless solution when exposed to air. Now, anhydrous calcium chloride. It is a deliquescent substance. So we write over there is a deliquescent substance. So what will it do if it's deliquescent substance? So it absorbs moisture present where? In the atmosphere, that's right. And dissolves in it. Forming its aqueous solution. And so that's how it becomes a solution. Now let us look at the last one. Metals form positive ions. Now what are metals? Metals have 1 to 3 electrons in the valence shell. So we'll say metals have 1, 2, 3 valence electrons. Hence, they lose electrons to acquire. Now they need to be stable, 1, 2, 3 valence electrons. So in order to have stable electronic configuration, they need to have the octet or duplet complete. And so they will have to lose these electrons 1, 2, 3 to acquire stable electronic configuration of the nearest noble gas. Now if they lose electrons, they will have more protons present. So thus they acquire positive charge on their ions. Let us come to question 1e. What do you observe when iodine crystals are heated in a test tube? Now iodine is a sublimable solid, so it is going to convert into its vapors. And so we will write purple vapors of sublimed iodine are seen. The second one, iron nails are added to copper sulfate solution. Now copper is lower than iron, so iron being higher than copper in the EC series, iron is going to displace copper from copper sulfate. So you are going to see this change. This will become FeSO4 and Cu will be displaced. So we are going to have the observations. Iron dissolves in CuSO4 solution, which is blue in color, forming FeSO4 is light green solution of FeSO4. Also iron nails get coated with pinkish brown copper metal. Lead nitrate crystals are heated strongly. Now lead nitrate, remember, it decrepitates. So it is going to decrepitate on heating, and it is going to evolve reddish brown nitrogen dioxide gas. So you will say reddish brown fumes of nitrogen dioxide will be seen, but in addition to that, the residue will be, so leaving buff yellow residue of lead oxide, which sticks to the glass, stains glass yellow. And also remember that oxygen will be evolved. Ferric chloride crystals are exposed to atmosphere for some time. Now ferric chloride, we know that it's a deliquescent substance, so it's going to absorb moisture, so you will have yellowish brown liquid is formed. So that is what you will see, because it's a yellowish brown powder and it's going to become deep yellowish brown liquid by absorbing moisture from the atmosphere. Blue copper sulfate crystals are heated. Now blue copper sulfate crystals are heated. It is CuSO4.H2O and is going to become CuSO4 plus 5H2O, which means the water of crystallization will be evaporated, gone, leaving anhydrous copper sulfate, the color of which is white. So you will say white, amorphous, anhydrous copper sulfate is left behind. Question 1F, state Boyle's law. Now these laws you have to know by heart: Charles' law, Boyle's law, gas law equation, and we have the Boyle's law. Temperature remaining constant, the volume of a given mass of a dry gas is inversely proportional to its pressure, that is V proportional to 1 upon P. You should be able to mention that. Now second one, I'm not writing. What is standard temperature and pressure? Standard temperature is 0 degrees C, which is equal to 0 plus 273 Kelvin. And pressure, it is 76 centimeters of mercury or 760 centimeters of mercury. Come to the third one. Now this is where we have to calculate the percentage of nitrogen in ammonium nitrate NH4NO3. Now the percentage of ammonium nitrate, the first thing you will need to do is find the molecular weight. So we will start with, it is question 1F. So question 1F, this is the third subpart. Gram molecular mass of ammonium nitrate. Now all the masses are supplied, as you can see over here. Nitrogen is 14, H is 1, O is 16. So nitrogen is 14 plus H is 1 into 4 plus again N is 14 and plus oxygen is 3 into 16, which will give us 14 and 14, 28 plus 4 plus 48, that is 16 into 3. That will give us 8, 8, 16 and 4, 20. Carry 2. So you'll have 4 and 4, that is 80 gram. Now you want percentage of nitrogen. So you will say mass of nitrogen is going to be 14 and 14, that is 28 gram. And therefore percentage of nitrogen is going to be mass of nitrogen upon mass of ammonium nitrate, and that multiplied by 100%. Mass of nitrogen 28 gram. Mass of ammonium nitrate, as you can see here, 80 gram multiplied by 100%. This 0 gets cancelled and you will have 4, 2 times is 8, 4 7 times, 2 1s and 2 5s, so which is equal to 35%, and that is our percentage of nitrogen. and that is question 1G. First part, balance each of the following chemical equations. So we have FeCl3 plus NH4OH gives NH4Cl plus FeOH thrice. Now here, in order to help us understand, we will do double decomposition reaction. Now FeCl3 has Fe having valency 3 plus. So when iron forms its hydroxide, it will become FeOH thrice, and 3Cl and 3NH4 will give me 3NH4Cl. Now check balancing. Fe is 1, Fe is 1, Cls are 3, Cls are 3, NH4 are 3, NH4 are 3, and OHs are 3, and it's balanced. Come to the second one. Ki plus Cl2 gives KCl plus I2. Now if I have Cl2, to balance chlorine I can put 2 here. So this will be 2 KCl. So 2K will be balanced by putting 2 Ki here and I2. So K is balanced, I is balanced, Cl is balanced. Let us come to our second part. Identify the substance which matches the description given below. White crystalline substance which sublimes on heating. Now sublimable solid we have very frequently come across is ammonium chloride. So here we will write it is a white crystalline, so ammonium chloride. A gas which turns lime water milky but has no effect on potassium dichromate paper is carbon dioxide. The other gas is sulfur dioxide, but that will affect potassium dichromate paper. So has no effect means carbon dioxide gas. A metal that cannot displace hydrogen from dilute hydrochloric acid. Now the one which cannot displace hydrogen will be below hydrogen in the EC series. So the best you can write is copper metal. Question 1H, match column A with column B. Column A talks about causes hardness of water. Now hardness of water will be because of calcium and Mg, that is magnesium salts. Now which one are the salts over here? It's an oxide, so you cannot take this. But this over here is magnesium bicarbonate, so that becomes your first answer. So that is your C. Causes ozone depletion is chlorofluorocarbon. This is kind of general knowledge. This is your D. Dehydrating agent will be concentrated sulfuric acid. You must know the property of concentrated sulfuric acid. Causes acid rain is nitrogen dioxide because it dissolves in water, the rainwater, and causes acid rain. Drying agent, of course, is calcium oxide because it is a hygroscopic substance. Now that finishes our section A, section 1, which was of 40 marks. I hope you have understood how to solve the questions. Thank you for watching. We come to section 2, which is for 40 marks. You have to attempt any 4 questions. But in this video, we are going to do all the questions so that you come to know how to answer all the questions which are given to you. Question number 2 says, the formula of chloride of a metal is MCl2. State the formula of its carbonate nitrate hydroxide. Now here immediately you have to look at this. MCl2, this 2 has come from here, and M1 has come from here. So the valency of M is, it is 2 plus. So carbonate we will write, which is 2 minus, and then crisscross will give you the common factor gone, MCO3. Let us come to nitrate. M2 plus, nitrate is NO3 1 minus. We'll do crisscross and that will give you M, and nitrate will be twice, so MnO3 twice. Hydroxide, again we write M2 plus and we'll write OH 1 minus. Crisscross will give you 2 OHs, so MOH twice. Come to question 2b. Write balanced chemical equations for each of the following. The first one is reaction of iron with chlorine. Now iron with chlorine, Fe plus Cl2, and that gives us FeCl3. It gives you the higher chloride. In order to balance chlorine, you will put here 2, you will put here 3. So chlorine is balanced and iron is balanced like so. We come to addition of silver nitrate solution to sodium chloride solution. So we will have NaCl plus AgNO3. Now this is going to give you double decomposition like so, and you are going to get the reaction NaNO3 plus AgCl, and that will be a precipitate. Addition of zinc to sodium hydroxide solution, so we will have zinc plus NaOH. Now zinc being amphoteric, it is going to form a complex salt Na2ZnO2 and is going to displace hydrogen. So you will have Na2, so you will have to balance like so. Now Zn is balanced, oxygen is balanced, hydrogen is balanced. Question 2c tells us draw the orbit structure for each of the following compounds. First one is methane. So now question 2c, first one, methane. The formula for it is CH4, and we have been given carbon equal to 6, which means its electronic configuration is 2,4 and your hydrogen is 1. So when we are looking at carbon, the carbon will have orbit structure. The first shell will have 2 electrons. The second shell will have 1, 2, 3, 4 electrons. Then you will have plus over here. Hydrogen will have 1 shell, plus 1 more hydrogen will have 1 electron, and plus 1 hydrogen here will have 1 electron, and plus 1 more hydrogen will have 1 more electron. And then it will have, this is what going to be like your pairing of the electrons, and as a result of that you will have carbon with the first shell of 2 electrons, and the second shell will have with hydrogen the 2 electrons. Here also the 2 electrons that are shared. Here also the 2 electrons which are shared, and here also the 2 electrons which are shared, and that gives us C single bond H, single bond H, single bond H, single bond H, and that gives us our methane. The second structure is magnesium chloride. So your magnesium chloride, again we will talk about magnesium chloride, the formula for which is MgCl2. You will have Mg given as 12 and the electronic configuration for Mg is 282, and for Cl it is 17, so the electron configuration is 287. So in order to show the orbit structure of formation, we will have chlorine here, magnesium here, and then again chlorine here. So Mg is going to have your 2 electrons in the first shell, 8 electrons in the second shell, and the third shell will have 1 electron and 1 electron, like so. Added to that is chlorine. It will have its 2 electrons, then it will have 1 2 3 4 5 6 7 8, and then the third shell will be 1 2 3 4 5 6 and 7. This chlorine, the same thing. Now chlorine has 7 electrons, it needs 1 more, and magnesium has to lose 2 electrons, so the 2 electrons are transferred, one to this chlorine and the other one to this chlorine, and as a result of that we will have Mg, which will be 2 electrons, then we have 1 2 3 4 5 6 7 8 electrons, and this side there will be chlorine, which is 2 electrons, 1 2 3 4 5 6 7 8, the second shell with 8, and the third shell also with 8 electrons, and this side the second chlorine, exactly the same, 8 electrons. Now out here you will see Mg was 282, chlorine was 287, this chlorine also 287. This is the electronic configuration, but as a result of transfer of electrons, Mg has become 2,8, and so it has become 2 plus ion, and I'll show it like so. Then chlorine, because it has gained 1, it has become 1 minus. This one also has gained 1 electron, so it is 1 minus, and that is how we will have Mg 2 plus and 2Cl 1 minus, and that gives us MgCl2. Question number 3. Name the industrial method for production of hydrogen gas. Now hydrogen gas is prepared by Bosch process. Name the catalyst used in the above process. The catalyst used is iron 3 oxide, which is Fe2O3. Promoter is chromic oxide. Write the balanced chemical equation for the production of water gas. Now, water gas is carbon plus steam. Carbon in the form of coke. What is our temperature? 1100 degrees C, and that gives you CO plus H2, and it is minus heat because it is endothermic reaction, and this is your water gas, CO plus H2, which is 50% CO and 50% H2. B. What is meant by group in the periodic table? The vertical columns in the periodic table, they are called as the group. Explain why the elements in the same group exhibit the same chemical behavior. Same group has same valence electrons, which determine the chemical properties. And hence the chemical behavior. In which group are the inert gases placed in the periodic table? That is your group 18 or 8A. C. Part of the periodic table is shown below with one element missing. Now this element missing is your period 3. So sodium, magnesium, aluminium, and this is phosphorus. Name the element. Now this is your phosphorus. Above table, answer the following questions. Name the lightest alkali metal. Okay, name the element that has duplet arrangement. Duplet is going to be helium. That is helium, but they say name, so you must spell it out. Name the lightest alkali metal. Now alkali metals are group 1A, that is starting from H, Li, Na, Lightest alkali metal will be Li, but not hydrogen because it is non-metallic in group 1A, so it will be Li, which is lithium. Continuing on the next page, name the halogen in period 2. Our period 2 is here, halogen is fluorine. So we'll write F. Identify the missing element, here it is, P, that is phosphorus. Question 4. A subpart, it's a numerical. Calculate the volume of gas X at STP. If it occupies 380 liters at 300 Kelvin and 70 centimeter of mercury. Now when we do a question like this, we will say question 4A, and we will just write the data that is given. It occupies 380 liters, which is volume, and there's temperature, and you are expected to find volume. So it will be P1, V1, T1, and here we will write P2, V2, T2. calculate the volume of the gas at STP. So volume is X. At STP, pressure is 76 centimeter of mercury and temperature is 0 degree C, which is 0 plus 273, which is 273 Kelvin. For P2, it occupies 380 liters, that is volume. So 380 liters at 300 Kelvin. So that is our temperature, and pressure is 70 centimeters of mercury. Now, according to gas law equation, we will have P1 V1 upon T1 equal to P2 V2 upon T2. We substitute the values. 70 multiplied by 380 upon 300, and here it will be 76 multiplied by X upon 273. So our X will be 70 into 380 into 273 upon 300 multiplied by 76. Cancel the zeros like so. 38 ones, 38 twos, 3 ones, 3 nines, 27, 3 ones, and so you will have X equal to 91 into 7 upon 2, which gives us which is 2 3s 6, 2 1s 2, 2 8s 16.5 liters, and that is our answer. Now we come to question B. B asks us to find the volume of the gas. A gas occupies 70 liters of at 27 degrees C. What volume will it occupy at 273 degrees C, pressure remaining constant? Now here you will see volume and temperature. Pressure remaining constant means we are using Charles' law. So let us use that, and let us write the details. We'll have V1 and T1, and we'll have V2 and T2. V1 is 70 liter and temperature is 27 degrees C, which becomes 27 plus 273 Kelvin, which gives us 300 Kelvin. They are asking what volume will it occupy, which means V equal to how much, and temperature is 273 degrees C, which means now 273 plus 273 Kelvin, which is going to give you 2 into 273 Kelvin. Now deliberately I am not adding because this is going in our calculations. So we will say according to Charles' law. Better to write which law we are using. We will have Charles' law expression V1 upon T1 is equal to V2 upon T2. V1, as you can see, it is 70 upon T1 is 300 is equal to V2 upon T2 so X is going to be equal to, this value will come here, so 70 multiplied by 2 into 273 upon 300. This will multiply to 717 multiplied by 2, which is equal to 7 2s 4, 2 7s 14, carry 1, 2 3 6 and 1 7, 2 6 is 12 upon 10, that is 127.4 liters, and that is our answer. Question 4c. Calculate the relative molecular mass of each of the following. The first one says ammonium dichromate. So, question 4c, the first one, ammonium dichromate. You'll have to find RMM. So RMM of, we will write the formula, ammonium dichromate is NH4 twice, Cr2O7 will be equal to, there are 2 of NH4, N is 14 as you can see here, plus H is 1, so 4H becomes 4, plus Cr is 52, plus O is 16, so that gives us 2 into 18 plus 104 plus 112, which is 36 plus 104 plus 112. $252, that becomes the RMM of ammonium dichromate, and that is your answer 1. We now come to hydrated copper sulfate. Let us write directly RMM of CuSO4.5H2O will give us Cu is 64 plus S 32 plus 4 into 16, that is 64, plus 5 into H is 1, so 2 of H is 2, plus 16. That gives us which is equal to 160 plus 90, which is equal to 250, and that is our answer 2. Question 5a. What do you understand by the term isotopes? Now, I'm having the ready answers so that it's easier for you to concentrate. Isotopes are atoms of the same element having same number of protons but different number of neutrons, and that is because atomic number is same and mass number is different. Why do isotopes of an element possess identical chemical properties? Now we already know what isotopes are, and so let us look at the answer. Isotopes have same atomic number, that is same number of protons and electrons. As many protons, those many electrons. Hence, they have same electronic configuration and same number of valence electrons. Hence, chemical properties which depend on valence electrons are the same. Let us come to our third subpart. Name the isotope of hydrogen which does not have a neutron in it. Does not have a neutron means it has only a proton, and so that will be protium. Come to 5b. State the type of covalent bonding in the following molecules. We have chlorine. Now chlorine, remember, has 7 electrons in the valence shell, so it becomes a single covalent bond. For nitrogen, remember, it has 5 electrons in the valence shell, so it shares 3 with the other, so it becomes triple covalent bond. And oxygen has 6, so it becomes oxygen sharing 2 electrons, and that will become double covalent bond. How would you distinguish between the following pairs of substances on the basis of the chemical test given in brackets? Now they are telling you sodium chloride and potassium chloride. For this we will have to make 2 columns because they've already given you flame test. So we'll write number 1, sodium chloride. For sodium, the cation is sodium and here the cation is potassium, and so sodium will be, if persistent golden yellow flame, then Na1 plus present. Therefore, sodium chloride present. For potassium, if non-persistent lilac flame, then K1 plus present. Therefore, potassium chloride present. We come to the second one, zinc carbonate and lead carbonate by dry heating. Now zinc carbonate, zinc is the cation and here lead is the cation. On heating, zinc carbonate will liberate CO2 and zinc oxide will remain, and here lead carbonate will give out CO2 and lead oxide will remain. So here for the second one, zinc is going to be the residue remaining. The color of it is, if residue of ZNO, which is yellow when hot and white when cold, then zinc carbonate present. And for lead you will have PbO, so you will say if residue of PbO which is yellow, that is buff yellow, sticking to the glass, then lead carbonate present. Question 6. State if the solubility increases, decreases, or remains the same with rise in temperature for each of the following compounds: calcium sulfate, potassium nitrate, and sodium chloride. Now calcium sulfate has been the exception. This is the only one, so this will be decreases. The solubility will be decreasing. Potassium nitrate increases. And sodium chloride slightly increases. We come to B. What is the difference between temporary hard water and permanent hard water? Now here I have the ready differences. Anytime they ask you differentiate, you should make columns like this. So when you make columns, you will have temporary hard water. The first quantity write first, second quantity write in the second column. The first point, temporary hardness can be removed by boiling the water. Permanent hard water, the hardness cannot be removed by boiling the water easily. Second one, temporary hard water, it is caused by the presence of calcium and magnesium bicarbonates which are dissolved in water. But for permanent hard water, it is caused by the presence of calcium and magnesium chlorides dissolved in water. Number 3, it is safe for drinking, but permanent hard water, it is not safe for drinking. Now let us come to our second part. Write the balanced chemical equation for the removal of permanent hardness in water. Now permanent hardness is caused by calcium or magnesium sulfates, so we add washing soda. Now washing soda is Na2CO3 and that will react with either CaSO4 or MgSO4, and we will have the double decomposition reaction taking place like so, and that will give us Na2SO4 and Ca will combine with CO3, it will form CaCO3. Now this can be filtered and the permanent hardness can be removed. In case of temporary hardness, it is formed because of calcium and magnesium bicarbonates. Now here again you can use washing soda or simply you can boil it off. So if you boil it off, let us take calcium bicarbonate. This is bicarbonate, and then we are going to add washing soda to that. So Na2CO3, and we will again have a double decomposition reaction, and that will give us CaCO3, which is a precipitate, and 2Na and 2HCO3, that is 2NaHCO3. You could have even boiled off this CaHCO3 twice, and if you were to boil it off, you will have CaCO3, and that will be a precipitate, and because it is HCO3, it will give you H2O plus CO2. So that is how we can remove the temporary hardness as well. Now let us come to our C part. Classify each of the following reactions as combination, decomposition, displacement, or double displacement. Now here what do you see? Aluminium has replaced Fe, it's become Al2O3. So this is displacement reaction. Next one, 2 KClO3 gives you 2 KCl plus 3 O2. Here you can see one compound has split into two compounds, and that is why we will have decomposition. We have the next reaction, BaCl2 plus Na2SO4. As you can see, it is double decomposition, which is double displacement as they are mentioned here. It has become BaSO4 and 2 NaCl. So this is double displacement. And last one, you can see that there are two compounds, they have combined together to give you another compound, and so it becomes combination reaction. Now we come to the last question. Question 7a, complete the following table. So we have elements phosphorus and potassium given here, and mass number is given for phosphorus as 31. Now mass number, remember, it is protons plus neutrons. Atomic number is going to be number of protons, which is also the number of electrons in the neutral atom. So if 15 is the number of protons, number of electrons also would be 15. And number of protons is the atomic number, which is number of protons as I have written here, thus also is 15. And number of neutrons is going to be total mass, that is proton plus neutron minus proton. So 31 minus 15, which is 16. Come to potassium. Number of electrons are 19, number of neutrons is 20. Now number of electrons and number of protons would be equal, so this also would be 19. Now protons plus neutrons, that is 39, would be the mass number, which is 39. Atomic number will be number of protons is 19. So that finishes our A part. Let us come to 7b. Write the electronic configuration of the following. Now calcium 4020, this is the mass number, this is the atomic number. So the number of electrons is going to be electronic configuration is going to be 20 will be in the first shell, 2, second shell will be 8, and 10 remain, out of which 8 will be in the third one and the fourth one will have 2. So we'll have electronic configuration 2882. For sulfur, electronic configuration again, we'll have 16 as the number of protons because it's the atomic number, and so it will be 2, 8. First shell will have maximum 2, second shell maximum will have 8, and then we will have 6 remaining, total will be 16. We come to the last subpart, that is C. State the valency of the element having 6 electrons in the valence shell. Now 6 electrons in the valence shell means it's a non-metal, and it will require 2 electrons to be accepted so that it completes its octet. So when it gains 2 electrons, it is going to have valency 2 minus. and the electronic configuration 2, 3. This is a metal because it has 3 electrons. Now 3 electrons are going to be lost, they are going to be donated, and therefore it is going to have valency 3 plus. Now that finishes all the questions of class 9 chemistry, the specimen paper. I hope you have understood every aspect of this particular paper and you have understood how to answer and present your work. All the best for all of you. Thank you for watching.